Hello everyone. My name is Jerrish, Senior Cloud and DevOps Trainer in Ekascloud. In today's session, we'll be working on this three-tier web application project. Okay. So this is one of the commonly used architecture in industry. So we will build this. So it has three tiers. One is web tier. Then the second tier is app tier. And the third tier is database tier. So in your regular classes, you might have learned a lot of concepts separately. In today's session, we will integrate everything and we'll build this highly available three-tier application. Okay. So end of today's session. So if people in the internet, if they send requests to the internet facing load balancer, so the traffic will be forwarded to the EC2 instances in the front end. So these EC2 instances are going to run Nginx web service. Okay. It will have some React based website configured. It will serve the website to the internet customers. And these websites will send API requests to the internal load balancer. And that internal load balancer will forward to the app tier servers. And this app tier servers will run Node.js application. Okay. And these Node.js applications are programmed to connect to the DB. That's how we are going to do. Okay. And in the database tier, we create RDS MySQL DB. Okay. So this is the overall architecture for today's session. Okay. In order to build this, it takes a lot of time. Maybe we'd also spend like less than $1. After the completion of this project, you have to also do cleanup. Okay, because we are going to use a lot of resources which will not come under free tier. If we keep on running, we'll be charged. Okay. So I'll also tell you how to do the cleanup by end of the session. Right. See, we may use Nginx web server within the Linux. I may use a lot of Linux commands here in the front end. It will use Node.js in the application tier. Again, I'll be using a lot of Linux commands here. So what I have done is I have already made a documentation. Okay, I have created a folder called 3-tier where I have already the application code, the website code, as well as the application code, what I'm going to place in the EC2 instances. Okay, it's there already in my local computer. Okay, I'll share this folder as well to you. Okay, and also I have created a step-by-step configurations, what has to be done in the AWS console. I'll share this as well. Okay, so when you are practicing, we will get all this application code. Okay, application code, website code, and the steps to do this project. Okay. So I'm going to start configuring it. So what I'll do is, see, this is the overall architecture, but I'll break down that architecture into smaller sections or parts, and I'll draw and explain what we are doing. Okay. Right. So this application code, website code, I have taken from the official website of Amazon. Okay, so this project is actually there in Amazon's website. I have taken the application code, website code, even the steps from the official website one. Right. If needed, I'll also share that official website link. You can go through it. But I found a lot of mistakes there. That's the reason I have made a lot of steps myself. Okay. Maybe if you're following my steps and if you're doing it, will be easy for you to do the project. Okay. Okay. Yeah. Let's start. Okay. So, like I said, I have broken this project into multiple parts, 6 parts. So first, let's do this part 1. So in this part 1, I'm going to configure the network setup and the security setup for this project. Okay. Right. So let me start this. So in part 1, so I'll follow the text file which I have. So the first step is I need to create a S3 bucket. Okay. So you can create S3 bucket with any name. Okay. This is step 1. So I'll go to my AWS console. I'll go to S3. As of now, I don't have any buckets. I'll create a bucket. So I'm giving the name as 3-tier app Ekascloud EC. And I'm selecting the region Mumbai. Not doing any other changes. I'll just click on create bucket. This is step 1. Okay. So the first step to our project is create S3 bucket. Now, why we have done this? So I'm going to upload the website code, application code in this bucket at later stage. Okay. That's the reason I have created a bucket. Okay. So step 1 is done. So I have created a S3 bucket in Mumbai region, but I haven't uploaded any data within it. As of now, it is empty, but we will upload the web application code and web application code and app tier application code at later stage in this S3 bucket. Okay. Right. Now, the second step is I'm going to create an IAM role. I'm going to create an IAM role with few permissions. Okay, so again, why I'm doing this? So in future, so we are going to launch EC2 instances. So this EC2 instances, which I am going to launch in the future, needs access to the S3 to fetch the data, the web data, website data, application data. Okay. So for that, if EC2 instance need to access S3, we need permission. So when I'm going to create a role and I'm going to attach permission for EC2 to access S3, that is one. I'll also add one more permission. I'm going to use a service called SSM, which I haven't actually taught in regular classes for the current batch, but I'll use the service called SSM, and via SSM, we are going to connect to the EC2 instances. Okay, so normally what we do to connect to the EC2 instances from our laptop via PowerShell, we log in, or sometimes we connect via the EC2 instance connect. But if the servers are in the private subnets, so instead of going to the public subnet and then logging into the private subnet instance, we can use a service called SSM. Okay, I'll be using service SSM. So that's the reason when I'm creating this role, I'm going to give permission for EC2 to access SSM as well. Okay. Right. So I'm going to create a role for EC2 and I'm going to add 2 permissions. Okay, so I'll go to IAM. I'll go to roles. I'll click on create role. So I'm trusting EC2. And I'm attaching two permissions. So one is AWS SSM managed instance for this permission. And the another one is AWS S3 read-only access. Okay. Right. So you can give any name for the role. I'll go with the name 3-tier app role. Okay, so I'm creating a role with the name 3-tier app role. I have attached two permission policies, S3 read-only access and SSM managed instance code. Okay, I'll click on create role. Okay, so I have told you why I am creating the role. So in future, when we launch EC2 instances, the EC2 instances is going to load the data from S3. That is one. And I'll be logging into EC2 instance with the help of a service called SSM. For that only, as well, I have given permission. Okay, right. Yeah, we have completed two steps. Okay. Now, in order to build this bigger architecture, we need subnets. We need VPC and we need subnet. If you see here, so there is a VPC, and within that VPC, there is in total of 6 subnets, 2 public subnets and 4 private subnets. Okay. So I'm going to create a VPC. So this is our third task. Okay. And for this VPC, I'll go with 10.0.0.0/60 as the network ID. Okay. So if you go to the documentation step, so here it is, create a VPC. You can go with any name for the VPC. And while creating the VPC, select the network ID as 10.0.0.0/60. It is possible you can select any other network, but I am choosing this network ID. Okay. See, before that, I also said, if you want, you can delete the default VPC. I said it is optional. Normally, we know if we go to VPC service in a region, by default, there will be a default VPC, right? It's not really needed to delete this VPC, but if you want, you can select this default VPC and delete it. Okay, if you delete it, you will see only the VPC which you created for the project. You will not have confusion as a beginner. So you can delete the default VPC. But I'm saying it's optional, right? So if you don't want to delete the default VPC, subnets, route table, internet gateway, if you can manage with proper tags. Or else you can select the VPC and delete it. Okay, so I'll delete it. So I'll select the VPC and I'll delete it. I'll acknowledge and I'll say delete default VPC. Why I'm doing? I said let's keep only the VPC, the project related VPC, the project related subnets, route tables, internet gateway, everything. Okay, so as of now, I have deleted the default VPC. If you see, I don't have VPC now in Mumbai region. I don't have subnets. I don't have route table, and I don't have internet gateway. Right? I have completely deleted everything. But I said it is an optional step. Okay, third step. Yeah, now I'm going to create the VPC. I'm going to create the VPC with the name 3-tier app VPC, and I'm going to select 10.0.0.0/16 as the network address. Okay, so I'll click on create VPC. I give the VPC name as 3-tier app VPC, and the network address is 10.0.0.0/16. That's it. And I'll click on create VPC. Okay, so I have created this VPC. So this VPC will automatically create a route table. Okay. So we know that when we create a VPC, VPC will create a route table. So we'll use this route table at later stage. Okay. Now I'm going to create subnets. Okay. So the fifth step is I'm going to create subnets, and I'm going to create 6 subnets. Because we are designing a highly available architecture, I'm going to create 3 subnets in 1A availability zone. And I'll create another 3 in 1B availability zone. Okay. So this is, assume this is 1A availability zone, and this is 1B availability zone. So I'm going to create in total of 6 subnets. In that, 3 subnets are going to be in first availability zone, and 3 other subnets are going to be in the second availability zone. So why we need this? These subnets are going to hold the front-end web servers, intermediate app servers, and the back-end database server. Okay. Yeah, so let's do this. So I have named this public web subnet AZ1. For this, it will be public web subnet AZ1. This is going to be public web subnet AZ2. Then private app subnet AZ1, private app subnet AZ1, and this is going to be private app subnet AZ2. And this is private DB subnet AZ1, and this is private DB subnet AZ2. Okay. Right. And this major network, this VPC network, is broken into 6 subnets for our use case. So this is going to be 10.0.0.0/24. And this is 10.0.10.0/24. This is 10.0.20.0/24. This is 10.0.30.0/24. 10.0.40.0/24. And this is 10.0.50.0/20, which means this VPC network address is broken into 6 subnets. These are the subnet address. Okay, I have documented it. You can, when you're practicing, you can follow this. Okay. Okay. So I'll go to subnets. Okay, I'll click on create subnet. I'll select the VPC, 3-tier app VPC. And the first subnet which I want to create is this public web subnet AZ1. I'll select 1A availability zone, and I'll go with 10.0.0.0/24. Okay. Then second subnet is private app subnet AZ1. So I'll again click on add new subnet. I'll give the name private app subnet AZ1. I'll select 1A availability zone, and I'll go with 10.0.10.0/20. Okay, so 10.0.10.0/20. Now I'll create the third subnet. Okay, I'll say add new subnet. Private DB subnet AZ1. Again, I'll select AZ1, 1A availability zone. I'll give the subnet addresses 10.0.20.0/24. Now the fourth subnet. Okay, so this is public web subnet AZ2. This is second availability zone. So I'll select 1B availability zone, and it is 10.0.30.0/20. Okay. Now fifth subnet. So the fifth subnet is private app subnet AZ2. I'll select the second availability zone, and the subnetwork address is 10.0.40.0/24. Finally, the last subnet, private DB subnet AZ2. We'll select second availability zone, and I'll go with 10.0.50.0/24. Okay. And if I click on create subnets, these 6 subnets will get created. Okay. These 6 subnets will get created. Okay. So I'll click on create subnets. Okay, so now if you sort the IP address CIDR, IPv4 CIDR from lowest to the highest, okay, you can see public web subnet AZ1, private app subnet AZ1, private DB subnet AZ1. These 3 are in first availability zone. So AP South 1A. Then public web subnet AZ2, private app subnet AZ2, private DB subnet AZ2. So these 3 are in 1B availability zone. Okay. So because in future we are going to create EC2 instances in both availability zone in the web tier, EC2 instances in both availability zone in the app tier, and database instances in both availability zone in the database tier. Okay, that's the reason we created a VPC with 6 subnets. Okay, so subnet creation is done. Now let's move on. So we'll create internet gateway and we'll attach it to the VPC. Okay. So I'm creating an internet gateway and I'll attach to this VPC which we are creating. So we know that people in internet, when they send requests, the traffic will go to the VPC via internet gateway. Okay, so I'll go to internet gateway. As of now, I don't have internet gateway. I'll click on create internet gateway. You can go with any name, okay, but I'll go with the name 3-tier app IGW. Okay, and I'll click on create internet gateway. Internet gateway is created. Now I'll attach this internet gateway to the VPC. I'll click on attach to VPC and I'll select the VPC which I have already created. That's it. So we created an internet gateway and we attached it to the VPC. Right. Now I'm going to create 2 NAT gateways. So I'm going to create 2 NAT gateways, NGWs. Normally in our regular classes, we might have created 1 NAT gateway, but today I'm going to create 2 NAT gateways. The reason is, see, NAT gateway is created in the public subnet, which is in an availability zone. Now, if one availability zone goes down, NAT gateway also will fail. In order to have a highly available architecture, so when we are having when we are using multiple availability zone, we need to create the NAT gateway in two different availability zones. That's the reason I'm going to create two NAT gateways. Okay. Right. I'll create one NAT gateway in availability zone 1 in the public subnet, and I'll create another NAT gateway in availability zone 1B in the public subnet. Okay, NAT gateway has to be created in the public subnet, because why we are creating this NAT gateway? So again, in future, when I create the EC2 instances, those EC2 instances, if it need to reach internet from the private subnet, it needs NAT gateway. Okay. Yeah. So let's create. So I'll go to NAT gateways. As of now, I don't have NAT gateway. So I'm going to create two NAT gateways. Okay. So I'll name it as NGWAZ1 for the first NAT gateway. So I'll click on create NAT gateway. I'll name it as NGWAZ1. I want this NAT gateway to be created in the first availability zone in the public subnet. So public web subnet AZ1. And we know while creating NAT gateway, we need an elastic IP. So I'll click on allocate elastic IP. IP address is allocated for the NAT gateway. And I'll click on create NAT gateway. Now this NAT gateway, what I created, is getting created in 1A availability zone. Okay, this is availability zone specific. Okay. Now while that is creating, I'll create one more NAT gateway. So I'll click on create NAT gateway. So this time I'll name it as NGWAZ2. Okay, and I'll place this NAT gateway in the second availability zone. So public web subnet AZ2. Okay, I'll select the second public subnet. Okay, second availability zone's public subnet. And again, I'll allocate an elastic IP for this NAT gateway. And I'll click on create NAT gateway. Right. So I have created two NAT gateways. Right. So NGWAZ1 in public web subnet AZ1, NGWAZ2 in public web subnet AZ2. And it needs elastic IP. There is two elastic IP. So this NAT gateway will not come under free tier. We need to do cleanup at the end of today's session. Okay. Yeah. Now let's create main route table. We'll add routes. Okay. We'll manage the routes for the VPC. Okay. See, while creating this VPC, one route table will get created. This route table, we can make it as a public route table. Okay. So this is going to be public route table. I am going to create two more route tables. Okay, I'll create two more route tables. So private route table 1, private route table 2. Okay. See, this route table is going to be public route table, where I'm going to add a route. Any network should go to internet gateway. So which means this route table can reach internet. Okay. And I'll associate the public subnets. These two subnets I'll associate to the public route table, which means if we have instances in the future in the public subnets, these EC2 instances can use this route table and reach internet. Okay. I told you I'll create two more route tables, but I'll not add route to internet, but I'll add route to NAT gateway. So I'll add any network route to NAT gateway. Again, in this route table as well, I'll add any network route to the NAT gateway. So this route table is for first availability zone, and this route table is for second availability zone. Okay. And I'll associate this private subnet and this private subnet to the first route table, and the second private subnet to the second route table. Okay. Why I'm doing this? Because in future, if I launch instances here, the instances here will use this route table, and via the NAT gateway, it can reach internet. Again, if I launch instances here, this instances can use this route table and reach internet. Via the NAT gateway, it can reach internet. Okay. Right. Okay, so this is what we are going to do. So I'll rename the main route table as public route table. So at the time of creating the VPC, we have one route table. If I go to route tables, we have one route table. I'll rename it to public route table. And in the root section, I'll add a route. Any network should go to internet gateway. Okay, and I'll save. Right. So I added a route pointing to the internet gateway. Now I'll associate the public subnets. So I want these two subnets to be associated to the main route table. So I go to subnet association, click on edit subnet association, and I'll select public web subnet AZ1 and public web subnet AZ1 and AZ2. I'll say. Okay, so now I'll go to route tables again. Like I told you, I'll create two route tables. One route table is for availability zone 1 and another route table is for availability zone 2. So I'll name it as private route table AZ1. We'll select the VPC. And in the root section, I'll say any network should go to NAT gateway in AZ1. I'll say, and I'll associate the subnet private app subnet AZ1. Okay, I want this subnet to be associated to this route table. Okay, I'll say. Okay, I'll go to again route tables. I'll create one more route table. Okay, so this is the last route table. So private route table AZ2. I'll select the VPC. I'll click on create route table. And I'll add a route. Any network should go to the NAT gateway, but to the NAT gateway which is in second availability zone. And I'll associate the subnet. I'll associate the private app subnet in AZ2. Okay, private app subnet in AZ2. Okay, so now we have in total of 3 route tables. So public route table, which has a route pointing to internet gateway, and public subnets are associated. Private route table 1, which has a route pointing to the first NAT gateway. Okay, so this is the first NAT gateway, and it has private app subnet AZ1 associated. Okay, and second route table, which has a route pointing to second NAT gateway, and second availability zone subnet is associated there. Okay, right. Okay, so we have completed the network part, right? Okay, so if you have any questions on this first section, if you have anything, you can ask.
Sir, while creating the subnets, how the Amazon will identify it is a public subnet?
In each section, I'll stop and I'll ask you. If you have doubts, you can ask.
Okay.
You can keep your doubts limited. You can note it down. You can even ask me later, okay? Because this is a time-consuming project. Shall I move on? Okay. Yeah. So now we have done the network setup for the project. Okay. Right. Now I'll go to security group section. See, we have route tables, we have routes, we have NAT gateway, we have private route tables, routes, everything. But for you to easily understand this architectural drawing, I'll remove all that. Okay. So NAT gateway is there, route tables are there, routes are there, but I don't want to have everything in the drawing. That's what I am deleting it. Okay. I'm removing it from the architecture, not from the AWS portal. Okay. Right. So even if you see here, this drawing also doesn't have NAT gateways, route tables, right? So this drawing is clean, right? Yeah, very similarly, I have removed those NAT gateways, route tables, routes. Okay. Yeah. See, I'm going to create security groups now. So 5 security groups. I'll tell you why I am going to create 5 security groups. See, we will create a load balancer, external load balancer, or internet facing load balancer. So from internet, people will send requests to that load balancer, that is internet facing load balancer. This load balancer is going to forward the traffic to EC2 instances. And this EC2 instances is going to forward the traffic to internal load balancer. Okay. And this internal load balancer will forward the traffic to application servers. And this application servers will forward the traffic to database. Okay. So this is how it is going to be. End of today's session. So now this load balancer should have a security group 1. This EC2 instances should have security group 2. This load balancer will have again a security group 3. This EC2 instances will have security group, that is going to be security group 4. And this database also will have security group, that is going to be security group 5. Okay. Right. So I know that the instances which I am going to launch in the web tier is going to listen on port number 80. So which means here the inbound rule should be 80 for the load balancer, and the load balancer will forward to these EC2 instances also on port number 80, which means here I need to allow port number 80. Here as well I need to allow port number 80. And this EC2 instances is going to send HTTP request to the internal load balancer. So here as well I need to allow port number 80. But this application servers, I know that it is going to run on 4000 port number. So here I need to allow port number 4000. Okay. And this EC2 instances, when it is reading data from the database or writing data to the database, so it is MySQL, so it is 3306 port number, which means in the first security group, you need to allow port number 80. HTTP request will come from internet. Load balancer will forward the traffic to the EC2 instance in the front end. Those servers also will run on port number 80. And EC2 instances will send API call to the load balancer, which will send on port number 80. But the applications are running on 4000, I know. So we need to make the targets in such a way that the request coming to 80 should forward to 4000. That I'll do when I do the configuration. And this application tier will forward to the database on 3306 port number. Okay, this is what we are going to do now. Okay, I'm going to create 5 security groups for the load balancer, EC2 instances, internal load balancer, application tier EC2 instances, and databases, which we are going to create in the future. Okay, so as of now, I don't have load balancer. I don't have internal load balancer. I don't have EC2 instances. I don't have database. Okay, I'm just creating the security group like this. Okay, 5 security groups. Okay. So let's create. So I'll go to security groups. Okay, this is a default security group. I'll create a new security group, and this security group is for load balancer. I'll name it as internet facing load balancer security group. I'll give name as SG1, description as SG1. I'll select the VPC and I'll add a rule HTTP from internet. Okay. So I'm allowing HTTP from internet. This is the rule. That's it. So click on create security group. So first security group is created. This is for the load balancer, which I'm going to create in the future. So I'm creating the second security group. So this is for web tier servers. Okay, I'll say web tier security group. I'll say description as SG2. I'll select the same VPC. I am allowing port number 80, but this time I'm not allowing from anywhere. So that is not a recommended best practice. See, we want only the load balancer to reach the EC2 instances. People in internet should always come via the load balancer to the EC2 instances. People should not directly access the EC2 instance. So while creating the second security group, I am allowing the sources internet facing load balancer security group. See, HTTP not from anywhere. I am allowing internet facing load balancer security group. So from the load balancer, the traffic should come to the second security group. Okay. This is security group referencing. Okay, I'll click on create security group. Now I'll create the third security group, internal load balancer security group. So again, I'll click on create security group. This is internal load balancer security group. Description, I'll give it as SG3. And I'll allow HTTP traffic. This time from the EC2 instances, which is from the web tier. So I'll select the web tier security group as the source. So when you are creating internal load balancer security group, you are allowing traffic from the web tier. Okay. I'll click on create security group. Now I'm creating the fourth security group. This security group is for the app tier. I'll name it as app tier security group. I'll give the description as SG4. And this time it is going to receive traffic on port number 4000. Okay, so 4000 TCP from internal load balancer. So I'll select internal load balancer security group. The traffic from internal load balancer is going to come to the application tier. Okay. Right, I'll click on create security group. Now finally, the last security group. This time it is for the database. So I'll name it as DB tier SG. I'll give the description as SG5. And the rule is you need to allow MySQL port number 3306 from the app tier. So you want to allow the app tier servers to reach the database. Okay, this app tier servers will reach the database. Okay, not from anywhere. Again, this is the security group best practices. Okay. Right. So for the internet facing load balancer, I have allowed the traffic from internet anywhere, port number 80. But for the web server security group, I allow traffic only from the load balancer. And for the internal load balancer, I allow traffic only from the EC2 instances, web servers. And for the app tier security group, I allow traffic only from load balancer, but I allowed 4000 port number because I know that I'm going to configure Node.js application on port number 4000. Okay. And this application tier will forward traffic to the database. Database queries will happen with SQL, MySQL. So it will be on 3306. So I allowed 3306 from the app tier. Okay. So this is the way you need to create security group. Okay. Right. Done. So we have created 5 security groups. Security group section is also done. So if you have any queries, you can ask, or else I'll move on.
Jerrish,
I'll
I
go to part
joined
2.
late. Sorry. So you created everything in Mumbai
So I
region,
created
right?
5 security groups in total. Internet facing load balancer security group. Then web tier security group. Then internal load balancer security group. Then app tier security group. And DB tier security group. Okay. Right. So we have completed part 1. See, some parts will go a little faster. So part 1 is done. Okay, so we have created the network and security setup for the project. Okay. So again, if you look into the main drawing, here you don't see any security groups. But okay, so we have created security groups. Right. Now what I'll do is I'll move on to part 2. Again, I'll delete all this from the architectural drawing, not from the console. Right. Okay.